Hey there, folks. We're coming at you live from reInvent. This is the What's Next show on AWS On Air, where developer advocates dive deep with the launch teams to learn more about what's launched at AWS in the past week. And thanks for joining us today. My name is Jenna Pedersen. I'm a developer advocate with AWS. And today I have with me Karthik Barthi, product leader for Amazon Neptune, and George Carapace, senior principal scientist at AWS. Hi. Thank you both for chatting with me today.
Thank you for having us.
Yeah. So, Karthik, before we dive in to talk about what has just launched last week, let's talk a little bit about graph databases. What are they and how are they different from relational databases?
Yeah. So graphs are fundamentally, it's a data structure that describes relationships using nodes, edges between those nodes, and properties, right? So when you look at applications like knowledge graph, which try to consolidate data, or identity graphs, which try to provide a unified view of the customer, or if you look at a fraud graph that's trying to detect for fraudulent patterns in your data, they fundamentally operate on billions of these relationships. Now, graph databases like Amazon Neptune is purpose built to manage these relationships as first class citizens.
Mhm.
So, what it means is Neptune provides flexible data models like the RDF, W3C RDF model with Sparkle as the query language, and the Apache Tinkerpop property graph model with Gremlin as the query language. And it can store terabytes of data and offer queries at millisecond latency. If you were to contrast this with a relational database are efficient to offer referential integrity, ACID transactions, and schema on write, which may be relevant to a certain class of applications. Now, for graph data sets, you don't want to be joining number of these tables, which may be expensive
Mhm.
and even cost prohibitive, right? So you want to be able to navigate an edge in the case of graph databases and offer those results quickly. The other advantage is with connected data sets tend to change a lot frequently. Now, you want to be able to store that in a graph databases that offer flexible schema and take advantage of your application. Now, let's take an example, right? So if you look at a movie data set with users, movies, and the genres that they belong to, there's a lot of data that can be stored as graphs, and you want to be able to gain insights from this using machine learning.
Mhm. Okay, so George, tell us a little bit about machine learning and why it's important.
Sure. So the reason that it's important is because machine learning allows us to make predictions much faster and more accurately. Right? To give you an example, without using machine learning, if I want to develop an application that predicts if a medical claim is fraudulent, I will need to talk to subject matter experts to learn things like which treatments go with which medical conditions, or which doctor specialties are qualified to treat which medical conditions, or which medical conditions are likely to follow from prior medical conditions, and so on. Once I've done that, then I will need to hard code all this information into rules and then use them to make predictions. This is both time consuming and also very brittle. The rules will most likely cover a subset of the fraud that is happening, and the system will not be able to adapt to changes on how fraud is being committed. Okay? Machine learning is designed to solve exactly that problem, and it's designed to do that thing automatically. What it's doing is automatically discovers fraudulent patterns and uses them to make predictions. It does not need to have access to subject matter experts, and it can adapt to how fraud is being committed, to how fraud is, to adapt to changes in how fraud is being committed.
Okay, so it's helping us make predictions faster and more accurately. But it sounds like it's actually really time consuming, and you kind of have to be an expert in machine learning to be able to do it in a quality way. So, Karthik, can you tell us a little bit about what just launched at reInvent that's going to help simplify this process?
Yeah. So we are very excited about the launch of Amazon Neptune ML at reInvent this year. Now, what Neptune ML does, it provides you easy, fast, and accurate predictions on graphs. So it's a new capability that's using graph neural networks, which is a cutting edge machine learning technique purpose built for graphs. And you can gain insights for your knowledge graphs, product recommendations, or your fraud detection use cases. Now, what Neptune ML also does, it's going to take the heavy lifting of selecting and training the best ML model for your graph data set. And you can access those predictions using graph APIs and graph queries that graph database developers are already familiar with. And it's powered by the Amazon SageMaker and the Deep Graph library. So in a few easy steps, you will be able to have the data in DGL, be able to run your train and run your models, and have your endpoints ready.
Okay, so you just used a term that I'm not familiar with, Deep Graph Library, DGL. Can you share what that means with us?
Oh, I'll be happy to do that. So DGL is which is the Deep Graph Library, which is abbreviated as DGL, is a software framework that is used to develop, train, and use a class of machine learning models called graph neural networks, that Patrick mentioned. So what graph neural networks are purpose-built models for making predictions on graphs, and they use deep learning to improve prediction accuracy over non-graph-based methods. There have been many studies in recent years that have shown that graph neural networks are over 50% more accurate than non-graph-based machine learning methods. So DGL itself is an open source project where AWS is a major contributor. And one of its key features is that it scales to the size of the graphs that are stored in Neptune. This allows Neptune's users to benefit from graph neural networks and make more accurate predictions.
Okay. So what are some of the use cases where our customers would like to be able to use this feature?
Yeah, the high level, what the Neptune ML allows you to do is allows you to solve two types of problems, is to make predictions on nodes and the edges in the graph. So if we think in terms of the type of problems that can be solved by making predictions on nodes, that includes problems like predicting if a medical claim is fraudulent, which is similar to what I just discussed before, predicting if a credit card has been compromised, of predicting if a player in an online game is cheating. But similarly, some other examples in where can also solve them via node classification are things like predicting the credit score of a customer or a customer's likelihood of churning. Now, in terms of the type of problems that you can solve by solving them by doing predictions on links, what you can do with that is you can use a thing to identify missing or erroneous information in knowledge graphs. You can use those things to identify if different entities correspond to the same individual. For example, entities in an online advertising system or accounts resulting through mergers and acquisitions. And another application is in the context of recommender systems, in which you can use it to identify what products to recommend to which customers.
Okay. So, Karthik, can you share how does this compare with machine learning with other database services that we offer?
Yeah. So just as context, right? If you look at AWS is continuously innovating and expanding machine learning capabilities and services, right? However, database developers and data analysts haven't benefited from those capabilities as much as, let's say, data scientists have. And the reason being that machine learning requires a lot of investment in learning the technology, which can typically take a few months. And database developers and analysts want to just use machine learning with the tools and techniques they are familiar with, like the query language they're already familiar with and have invested in. So when you look at the machine learning launches, right, you have Neptune ML, Aurora ML, Redshift ML, Athena ML, right? So fundamentally, what we're trying to do is have an easy way so database developers and analysts can start accessing those machine learning capabilities. And specific to Neptune ML, like George called out, we are using the graph neural networks, or the GNNs, which is purpose-built for graph data, which means any developer with the data in Neptune can now start accessing predictions in a matter of hours instead of investing it in weeks.
Okay. Before we see all this in action, George, can you just share a little bit how this works under the hood?
Sure. So in order to use a Neptune ML, a developer has to perform, 4 primary steps. So the first thing that a developer needs to do is use a Neptune export service to export the graph that would be used to train the machine learning model into an Amazon S3 bucket. Once the thing is done, then the developer needs to use a REST API to prepare the data for training, following by using another REST API to train the machine learning model. And once the training is done, they use a REST API to load the model for actually making predictions. Right? Once the thing is done, then they can use Gremlin to execute queries in order to access those predictions. And Catherine will actually illustrate all of those steps in the demo that she's going to give us right now.
Sure. Let me share my screen. Cool. So in this demo, we're going to show you how you can easily get started with Neptune ML, right? So what you're seeing on the screen is a blog post with a walkthrough of the Neptune ML capabilities that went out as part of the launch. Now, imagine that we're building a movie streaming application, right? And what we want to do is we're displaying the list of movies, their genres, and for a given user, right? And what we want to do is we want to infer the list of movies that a specific user is going to rate highly. And we use a technique called link prediction. So link prediction is a machine learning technique that tries to infer missing relationships in data based on ranking of the source or destination vertices. In our example, we're going to use the movie lens dataset that's was collected by the Group Lens project from the University of Minnesota. The data set contains users, the movies that they have rated, and the genres that those movies depend on. And there are edges that connect those vertices, right? So as you walk through the blog post, you will notice that there is a CloudFormation template link. So that's what I have used just to switch tabs. I have run that stack beforehand. And once that is complete, you can go to the outputs tab and see a bunch of parameters, right? So this includes your database information, the ARNs that it has created, an export service, and a Neptune notebook. The Neptune notebook is interesting because it's going to give me a sample that I can use. So here's the notebook that it created. And I'm going to open this notebook. And in the notebook that you will see 3 examples provided. There's one for node classification, there's another for node regression, and then the third one is link prediction. These are examples that you can try out. And for this demo, we're going to focus on the link prediction use case. I have opened that window just to save time. And if I walk through the steps, the first one is to really install a library that helps me connect from my client to the server, Zigbee for library. It takes a few seconds to just install it. I've run this library before. And once that's done, you have to set 3 parameters, right? There is an export URL, so that triggers the export job. Now I get the URL from my CloudFormation script. So if I go scroll down, you can see that there is an export API URI. That's what I've filled into my first parameter. The second one is an S3 bucket. This is where you store the exported data and the machine learning model. I have a pre-created bucket. The point to note is that the region of the S3 bucket should match that of the cluster. In this case, I've used London. And the third one is the IAM role, which is also another property I get from my CloudFormation output, right? Now, if I run this command, what it's going to do is it's going to check whether the cluster parameter group called Neptune ML is enabled on the cluster. That's a prerequisite. Once that's enabled, you can use that feature, and that parameter is available on engine versions 1041 and beyond. So once that's done, I have my cluster, things look good. So I need to load data into my cluster. So the way I do it is I run this command, and what it does, it's going to connect to the Movie Lens website, and it's going to collect the data and format it in a way that's understood by Neptune, which is a Gremlin CSV format. We're building a property graph in this case, and that's the output that you see in this S3 bucket. I'm going to copy this and run a bulk load command, which is a magic command here, paste that S3 bucket, choose CSV as my format, and there are a few defaults that it's already filled in, and then I'll submit the job. Depending on the data set, it should take like a few minutes in this case, and your data set will be available for query purposes, right? So this is the data model that we talked about. Now, let me go ahead and quickly show a graphical view of how this data looks like, right? So I'm going to look at the data set for, let's say, user 4 and the list of movies this person has rated. So let me go to that graph, zoom in a bit, and I can move him. And you can see that there are a bunch of these movies that this person has already rated. This is good. So we have our data loaded. I can also look at what vertices are available, just do a group by on my label and see that there are 4 vertices. I can do a similar query on my edges and see the edges that are present and a count. So it looks like I have my data in my cluster now, and I need to plan for my export. I can choose any user. The walkthrough uses user 1 and it removes the edges. But for my demo here, I'm going to use user 4. It shouldn't really matter. Once you have a trained model, pretty much you can run the link prediction for any user in your database, right? So the next step is to export the data. Now, what we need to do is you need to identify the features that you want to export. And feature is really a property of your graph. And there are two kinds of those properties, right? One is a numerical feature, which here age is a great example of the user. And there is also a category feature which takes a value from a fixed set, right? And here occupation is a great example. Now, what I have done is I've used those features to define my JSON configuration, right? This is instructing my export service on what needs to be made available for machine learning. For example, title is a string, and I have used a word2vec to have a vector representation of the data. And I have age, which is numerical, and I provided a bucket like I called out earlier for my export. Run the export job. In this case, it takes like about 2 minutes for this data set. And what you will see is the S3 file location. Just to make sure that we have the data set, I can go into this link prediction bucket, go into that folder, and there you see that Neptune export will have the list of data sets, including the JSON configuration that was provided to the deep graph library. Now, all I need to do is start training my machine learning model, right? And there are 3 steps that the machine learning training process involves. One is doing a data processing where the data format is made available to the DGL system that it can process for training purposes. The second step is a model training job, which selects the right model training strategy and then runs a hyperparameter tuning job in order to arrive at the best model for your graph data step. And finally, once you have the model, we'll publish it in SageMaker, and you should get an endpoint that we can use in our Gremlin queries, right? While there are 3 steps, what we have done is provided a utility that just gives you all of these 3 commands in a single step, right? I have the training, processing, and an endpoint parameters passed as the arms and the job IDs in this command. And the duration of this step depends on your size of data. For my link prediction use case, it typically takes a few hours. And once it's trained, you can query it any number of times on your Gremlin side. The output from the command is a link, an endpoint name for link prediction. So I'm going to copy that and go into the Gremlin syntax, right? Now, when it comes to graph queries, we have added extensions to Gremlin that let you access the machine learning capabilities, right? And these extensions with the with clause have different predicates that you can use. The 3 predicates that are important are the Neptune ML endpoint, where you specify, hey, what are you querying? This is the output from the previous step. Then you can use the IAM role on, so your service has permissions to access the different SageMaker capabilities. And finally, the query itself will use Neptune HashML.prediction and this is where the actual prediction occurs. So the quick walkthrough on the query is you're going to say a g.v, so you're picking on user 4, navigating via the rated label, and you're saying that the with ML prediction is that it's a prediction, it's a predicted label, not an actual data that's in your graph database. Navigate to the movie vertices and find out what they are. So let's run this query. And you see that the system is calling out, there's a specific movie that it's recommending. So let's just copy that. And I also have my original query, the data in my graph. Let's run that. So this is the same visual that you saw earlier for user 4. So let's go back and see. You see that this particular movie is not part of the current set, which means that this is a good candidate that you can recommend to the specific user and which would be highly rated, right? So you can carry out other Gremlin queries, which also navigate beyond that predicted vertex. You can actually go look at the genres of the predicted vertex, right? So this is going beyond the machine learning prediction. So let me run this query. I think I'm using, yeah, this is using user 1. So if I go to the graphical view, so I have navigated to the predicted movie for user 1, and navigated further to say that, hey, that specific movie has 2 genres, is an action and a thriller that's associated with this specific movie. So what we've seen is in a few easy steps now, you're able to predict movies that this user will highly rate. And it's always a good practice once you have used the service and the demo, you can clean up, you can delete the endpoint, you can also go back to your CloudFormation stack, and you can always select the stack and always delete it. So you save on cost in this case. We definitely encourage you to try out each of these 3 examples and let us know your feedback. Over to you, Jenna.
Thank you. Okay, thank you so much for sharing that. I'm looking forward to digging into this. Can you tell us how folks can learn more about Amazon Neptune ML and get started with it?
Yeah, so we have a bunch of blog posts, like the one I showcased, that's definitely an avenue. But the quickest and the easiest way that we found was to use those graph notebooks, right? So there is sample data. You can try out those samples, different capabilities, and see that in action. So that's a great way to get started.
Okay. And can you just remind folks out there how we have to enable this in our account, right?
Correct. So you go to your cluster parameter group, and you should see the Neptune ML as a flag that you need to flip it. You also have 2 other parameters, like the on and the endpoint that I use in my Gremlin queries can be added to the cluster endpoint, so you don't have to specify it in the query each time. So yeah, that's a good point.
Great. Well, we are just about out of time for today. Thank you both so much for joining me and talking about this. I really appreciate your time. As a reminder, you can catch the rest of the AWS on-air streams right here at the same URL for the rest of the week. And you can get more service launch announcements with deep dives just like this one, customer interviews. We have some game shows and some industry roundups as well. So next up, I think we have Howdy partner with Datadog. Thank you.
Thank you.
Thank you.